Here's a brief introduction to the types of chemical reactions that we will observe in chemistry. This first slide actually shows you some great representations of the patterns that we will see on the following slides. But before we get into those types of reactions, how do you know if you've seen a chemical reaction? There are either going to be changes in properties or even changes in energy that we can still observe. For example, a change in color, as we might see on the Statue of Liberty, where copper changes over time, it goes from that orangish color that we're so familiar with to a green color. The production of gases that we see in the form of bubbles is another way that we know a chemical reaction has occurred. When an odor changes or is produced, that's another example of a chemical change. The formation of a precipitate or a solid when two liquids react is another example of a change in chemical properties. Additionally, we might see a warming or a cooling, or we wouldn't see that, we would feel that if energy is either given off or absorbed during a chemical change. And then finally, another example is the release of light during a chemical reaction, as we see in fireflies and other bioluminescent organisms. So, first reaction type is called synthesis. The generic form here is A plus B yields AB. More professionally, is when a compound is formed from the combination of two or more simpler atoms or molecules. A very silly cartoon here is showing two people who are attracted to one another and then begin to dance. So two individuals then make one group after the reaction. More formally, potassium and chlorine produce potassium chloride. And that's in words, but in molecular form or in the formula form, we have two potassiums in solid form plus a diatomic chlorine molecule in gaseous form, create two molecules of potassium chloride in a solid. Decomposition is simply the reverse of synthesis, where a compound breaks down into its constituent parts. So it'll break down into two or more simpler atoms or molecules in some cases. And to revisit our friends, it would be the reverse, where the couple has a tiff and then they break apart. So in this case here, for example, mercury 2 oxide can break down into mercury and oxygen as shown in the diagram. Here you see two molecules of mercury oxide in solid form break down into two atoms of mercury in liquid form and a diatomic oxygen molecule in gaseous form. So synthesis and then decomposition are the reverse of one another. Now single replacement adds in a little bit more complexity, where we have a compound and a single element will yield the same idea. However, one of those elements has been replaced by the single one. So this is when a pure element, typically a metal, will replace one of the elements that is in usually an ionic compound. So here, to visit our friends, we have a couple happily dancing and another person comes along and suggests that maybe he may come in and take the other one's place. And so in this case we see B is replaced by A. As a real example, we have lithium and water forming lithium hydroxide and hydrogen. And so in the formulas, we've got two lithium atoms combining with two water molecules in liquid form, forming lithium hydroxide and hydrogen gas. So that's single replacement. Now adding one more layer of complexity is double replacement, but it's the same idea of what we looked at before, aside from the fact that we now have two compounds that are reacting. So two ionic compounds react, and then the anion, remember that's negative, and the cation, the positive ion, will switch places. So to visit our couples, we have two couples, A and B, and C and D, and they're happily dancing along, and simply they switch partners. And so in this case, notice that we often see a precipitate that is formed. So silver nitrate and sodium chloride are our examples, pay attention to the words and how they switch places, silver chloride and sodium nitrate. And so here we see that with the chemical equations, silver nitrate in an aqueous solution, meaning it's in water, and sodium chloride, also in an aqueous solution, produce silver chloride. Now that's the precipitate we see, the solid precipitate, leaving sodium nitrate in aqueous solution. Combustion is a unique one. Here we're not going to visit our dancers, plus somebody would be on fire, so that's never good. The general equation is fuel, some hydrocarbon, CXHY, and you can insert various subscripts there depending on the fuel type, plus some oxygen will yield water and carbon dioxide and energy. So this is when a fuel burns with oxygen in order to produce heat, and then it releases water and carbon dioxide as waste. So CO2, I think we're familiar with that being released by fires, and it actually will put out fires and water as well. For example, cellulose is a hydrocarbon, C6H10O5. If we have a couple of those molecules plus 17 oxygen molecules, this will release 12 carbon dioxide molecules, 10 water vapor molecules, and some heat energy. So sometimes if you don't see a flame, there's another way to tell if indeed combustion has happened, and that's if you see some condensation occurring. In other words, you see some liquid water. So the water vapor gets condensed down into liquid water. So as a little practice here, if you want to look at these equations, and feel free to pause the video here and see if you can identify these types of reactions. And I'll go ahead and reveal the answers. So the first reaction there, hopefully you came up with double replacement. And the next one has a pretty big giveaway in the products, combustion. Third one is synthesis. Fourth example, single replacement. And then finally, decomposition. Hopefully that was helpful and that you have learned your 5 types of chemical reactions.